So this is my first attempt at a video here at the house. This is what I'm doing on Thanksgiving break and the snow days. So yeah, I hope you're enjoying your time, whatever you're doing. But now it's time to work on some quadratics. I should be safe in Boston now and learning a lot. And so it's your job to learn something too. Let's get going with chapter 5, our quadratics chapter. And this is the first section. So the first section is just an introduction to quadratics, what they look like on the graph. But we're going to start with the equations themselves. What makes a quadratic function, and how will we recognize it? All right, so let's go ahead and get started with some examples. Let's start with the definition. All right, so the definition, a quadratic function is a function that can be written in this form. So here's the standard form of a quadratic function. Let's use function notation. Some number times x squared plus some x term plus a constant. So the defining factor is this x squared piece, so a variable squared. So that makes it quadratic. We do have one important restriction here, and that is that a cannot be 0. All right, so if a is 0, let's just imagine that right there is 0. Well, then this whole piece, this term disappears, and what we're left with is linear, right? It looks a lot like y equals mx plus b. So this would make a straight line on the graph. That's a whole different family of functions. So this is what a quadratic. This is the standard form of a quadratic. So our first goal is to write quadratics in standard form and identify the ABCs. We have to know our ABCs. It's really fundamental. So let's do some problems like that. All right, so here are the first two examples of quadratics. I'll tell you they are quadratics from the notes page. So hopefully you can fill this in as you go. All right, so I think our directions here are to write the quadratics in standard form, and then let's identify A, B, and C. So, excuse me. All right, so this one's not in standard form. Standard form, it goes in order of largest degree. So degree is the power on a variable. So this is the first term. The squared term is going to be the first term here. So let's go ahead and write that first. I don't know if these work. All right, so let's go -3 x squared. And then the x to the first power, so just the 2x, that's our next term. And then our last one is the constant. It's a positive 15. All right, so in this case, a is with the x squared. That's my coefficient of x squared. So a is a -3, b is a positive 2, and c is 15. Awesome. All right, so the next one, we go a different color. Example B, this one's a bit more complicated. It'll probably be a quadratic. But let's go ahead and see what it looks like. So I'm going to do the double distributive property. I don't really believe in FOIL. So let's call it the double distributive property. So I'm going to distribute each of these two terms in the first binomial to this piece. Now I'm going to write an extra step here that I don't usually show, but it's going to be useful because when we do some of this backwards later in the unit, it'll be nice to see this. All right, so I'm going to take this first 4x term and multiply it by this whole second binomial. So I have 4x times 3 minus x, and then I'll take that positive 1 and multiply it by both terms in that binomial as well. So it looks like this. And now I can distribute each piece and combine like terms. So 4x times 3 is 12x. 4x times a negative x is negative 4x squared. 1 times 3 is 3. And then 1 times a negative x is negative x. So now that I've gotten rid of all the parentheses and the grouping symbols, I'm going to combine my like terms. And again, I want to put it in order from my largest degree term to the constant. So I see the x squared here. So let's do that one first. So my first term is negative 4x squared. And then I will go ahead and put my x terms together. 12 minus 1 would be a positive 11. And then the last term is this constant here, 3. All right, so my a is the coefficient of the x squared term. My b is the coefficient of the x term. And my c is the constant. Right? So I've got standard form of a quadratic and my ABCs. All right, so the next two problems, I'll go and write those down. I think you see them labeled C and D on your notes page. Those are some U-triads, right? So why don't you go ahead and try C and D. Let's pause the video and then maybe give you 2 minutes and then go ahead and push play and you'll see if what you did matches mine. All right, good luck. Okay, here are the next two problems. Hopefully you got a head start. Got something that you like as an answer. So I'm going to go ahead and put these in standard form. So first I'm going to get rid of my parentheses by distributing. So let's go ahead and distribute that 3x. So I have 3x times x is 3x squared, and 3x times a negative 5 is negative 15x. I don't know if you can hear that, but my kids are playing some hilarious game that involves throwing a ball in the house. So I'm going to ignore that for now as long as nobody's hurt. All right, so here's my first example C in standard form. A is 3, B is a negative 15, and it looks like I don't have a C term or a constant term here, but that's okay because we have a number for that. So that would be 0. Remember, C can be 0. Only A cannot, but B can be 0 and so can C. So that's fine. Awesome. So here's a standard form and ABCs. All right, let's go ahead and try example D, double distributive property. So let's do 2x times both of these. And then negative 5 times that same group. Kind of went off the edge there, but that's okay. I think you can see it. All right, so when I distribute this, 2x times 2x is 4x squared. That'll be my leading term. 2x times 5 is a positive 10x. Negative 5 times 2x is a negative 10x. And negative 5 times a positive 5 is negative 25. All right, so last step. Let's combine like terms and put them in order. I already have my 4x squared. My x squared term comes first, and then I'll combine these. That makes 0, right? They're opposites. And so I'm left with a negative 25 as my constant. So A is 4, my x squared term. B, there is no B term, so B is 0 in this one. And C is negative 25. Awesome, so I hope you got those right. There you go. And there you go. All right, so let's go ahead and move on and talk about what a quadratic looks like. And so sort of just label the parts. This is the quadratic function, right, as a sort of an equation. But now let's talk about what the graphs look like. And many of you have seen this, or maybe you don't remember everything, but I'll go ahead and start another video so these don't get too long, and we'll talk about the anatomy of the quadratic graphs.